Yes, hi. Hi everyone. Good morning.
Good morning, Vipul.
Morning, people.
All right, I'll just share my screen. Meanwhile, if you have any questions in the last session, you can ask. Yes. Do you guys have any doubts? All right, I'll consider silence as a no. Uh, so in today's session, we are going to start with uh, let me open this first. Why this thing? Okay, in the last session, we have seen this. Okay, how to select a single column, right? How to display sales column, also how to display your profit column. All right. Uh, Now in this session, let me create new folder for this. Let's rename this as 27th October and let's upload that data, sales data. Sales data, this one. Let's create new notebook, right? Uh, in today's session, we are going to start with another Pandas function, which is known as indexing or slicing, right? So indexing and slicing, which is same as in the case of list that we have discussed. So there are multiple ways to select rows and columns from a from your data frame. There are multiple cases. Uh, I'll just write down theoretically first. Let's write down this. There are multiple ways to select rows and columns from a data frame or series. In this segment, you'll learn how to select rows from a data frame. Second, you are going to select columns from a data frame. Third, we'll select subset of the data. We'll learn how to select subsets from or of a data frame. So selection of rows in data frame is similar to the indexing that you saw in NumPy arrays. The syntax is you need to select data frame. You need to give starting index for that, and you need to give end index for that, and close this. We'll subset the rows according to the start and end indices. However, you can have all the columns for each row using function provided above. With the introduction of column labels, we are going to see how do we select columns, which is no more similar to that in arrays. Let's understand this. How we can do that? So quickly, we'll just do all imports. We'll go with importing numpy as np, import pandas as pd, and we'll require matplotlib as well, which we are going to discuss after some time. Importing matplotlib dot pyplot as plt. Right? I'm going to take out that data df sales is equals to pd dot read underscore excel, and let us read that sales data which we have with us. Right? I'm going to write down sales over there. Now we are going to create sales and profit data that is read uh, in the form of data frame, which is known as sales. So what is this data? This data is all about sales and profit of different market of different region, right? So uh, if we have to we don't want this rows indexes, what we'll do is we'll write on index underscore call is equals to 1, which we already know, right? This thing we already know. Now, as you know, how do you select a single column? We'll start with basics. Example 1, which is known as column indexing. How do you select a single column? Let's say I want to display sales column. How can we do that? Yes. How can you select sales column?
Colon -1.
You can do that, but I
Okay.
was expecting this. Or you can write down the sales dot sales, right? We have two ways. Uh, which we already have discussed. How do you select multiple columns? This is just a quick revision of your last session. How do you display sales and profit column together? Sales double square bracket. Yes or no? If you are dealing with multiple columns, you should go with the double square bracket. This is how you get multiple columns. Now, uh, I here you have rows not in the form of 0 and 1. 0, 1, 2, 3, 4. You don't have these indexes for row, right? Your indexes are Western Africa, Southern Africa, Africa, Eastern Africa. These are your indexes. So in order to select your row, in order to select or do row indexing, what you have to do is you have to write down its name for that particular row. What I'm trying to say is this I want to display data for Southern Asia. So LOC accessor text row index and column index. Uh, let's say sales.loc, and I have selected, let's say I want Southern Asia row. So Southern Asia row is this, and you can select the columns that you want for Southern Asia. Suppose I want sales column only. Excuse me. I only want sales column for this. So I'll get Southern Asia sales, which is this one, right? Excuse me. But if I want all the columns out there, simply I'll not mention anything. I'll only write down comma. So I'll be getting all the columns out there. Number of orders, profit, and sales. So sales.loc will give you the uh, access to select rows and column. Here, the important point is if you use LOC function, you have to use square bracket. The first argument that we have before comma, that is for your row indexing. Second is for column indexing, right? So you need to specify row first. Obviously, you can give row start and end like this. Suppose uh, I have 0, 1, 2, 3, 4 as the row index, right? So I'll write down dot .loc. Suppose I want from row number 1 to 3, I'll write down 1, 2, 3, comma. Let's say for all the columns, so I'll not write down anything. What I'm trying to say is, here we have done indexing index column. So we were having row index as the column, that is region. But most of the times you don't have to do this thing. You simply read the data, just like your plain vanilla uh, data like this, which will be having row index as a number. Here also you can do, uh, you can use LOC, but you have to use row indexing like numbers. Let's say I want row from 1 to 4, and I want for all the columns. So I'll write down over there sales1.loc 1 to 4 for all the columns out there, right? To be more specific, if I want only let's say market column, so I'll write down market. I'll get market column. Uh, Suppose I want columns from market, region, number of orders, and profit. I want this one. So what I'll do, I'll write down column from where I want to start. So market is the one. Till which column? Profit, let's say. I'll write on that. So I'm gonna get market, region, number of orders, and profit, right? So this is another thing that I wanted to explain. By using LOC accessor, you can take subset of data, right? Similarly, we have another accessor which is known as integer based indexing. So here it will not take the column name as the index, meaning that you have to specify the number for index. So only numbers are allowed. LOC can take column name. You can write down column name over there. But in LOC, let's say sales1.iloc, this iloc, I want from row number 1 to 4, let's say, and for all the columns, let's say. So row number 1 to 4, if I write, it is a exclusive of the last operator. You'll not get row number 4 if you write 1 to 4. If you want fourth row, you need to write down 1 to 5. So you'll get 4. It's just like your range function for I in range. If we used to write 1 to 5, it used to give us only 4, right? We are not getting 5. Yes or no? It's just like that. We are not getting 5. Here also we are not getting 5. We'll get 4. But in LOC, it's just a minor difference. That is not very important, but you should know that 1 to 4 will give you last as well, and market to profit will give you profit as well. Here, if you write down indexing, let's say this market has index 0, this is 1, this is 2, this is 3, and this is 4. You want market to profit. So most of you guys, what you'll do is you'll write down from index 0 to, let's say, 3. But you'll not get 3. If you want that index, so you should write 4. Right? Even though 4 index is for the last column out there, which is your sales, but 0, 1, 2, 3, 4. If you want profit, you should write one more number for them. That is 4. Right? Here, as I have explained, this is integer based location, so you cannot give column name. It will not take column name over there. It will throw the error, but it will take integer. So if I don't write anything, all the columns will be there. In the beginning, if I don't write anything, it will take from beginning here. If I write 1 to nothing, it will take 1 to end. And if I write 1 to 5, it will take 1, 2, 3, and 4. That's what we have for iOS. Is it clear, this one? ILOC and LOC, is it clear, everyone?
Yes, Vipul.
So you should try this out, make a combination. You can create n number of questions. Let's say suppose this is your data. The questions can be, how many rows do we have total? If I check info, we have 23. Okay. So question 1 can be, get row number 3 to 17 for column market and region. Right? Yeah, one more thing. If somebody have this question, let's say here we are getting consecutive columns, let's say market, region, number of orders, and profit. What if I want market, number of orders, and sales? What can we do for that? So you have to create a list in which you only specify the column that you want. Market, comma, number of orders. The best way, as I told, is to just copy this column name and paste it over there, and sales. So you are going to create a subset of a data in which you have only market, number of orders, and sales. Right? So this is one thing that I wanted to explain. Anyway, this is very simple, but you just need to try this multiple times to get your hands on this. So you can have this question, get row number 3 to 17 for column market and region by using ILOC and LOC. That is one thing. We have negative indexing as well, which we are going to see. Negative indexing means biasing. Most of the times, LOC will fail to do the negative indexing. By using ILOC, you can get the negative indexing. Let's say if I want last row number for all the columns. So this is your last row number. If you just check sales, okay. If you just check sales1.tell, and what's your last row? So that is your this, right? USCA, Canada, 497246. This is your last row. If you want last 5 rows, let's say if you want the same output like this, sales.tell by using ILOC, you should write -5 to 0, which will give you the same output like this, right? And you can obviously try and do n number of things. Suppose if I give you this question, I want only this part in the output, which is Eastern US 443 47462. This part. So what should I do? As you know, this is -1 row, this is -2 row, this is -3 row, this is -1 column, this is -2 column, this is -3 column, this is -4 column. So what do we want? We want to start from -3 row. We want to end at -2. But if you write -2, you'll not get -2 because it's ILOC. You should write ILOC -3 from start. End should be -1. If you write on -1, it will take -2, right? And the columns, you'll give comma. For columns, it should be starting from -4, right? It should end at -1. If you write -2, it will not take that. So you should write -1. If you write down this, you'll get the output. Let us try this out. If I write -3 to -1, comma, -4 to -1, I'm gonna get the same output which I have written over here, right? So I'll suggest you to create n number of questions from by your own to create a subset of data like this by using negative indexing. This is just a game of practice, that's all. It's not very difficult. So I'm creating different questions which you can solve by using negative indexing. You need to solve this, right? I'm writing down questions over here by using negative indexing by using ILOC to solve this, right? So you have uh, two questions. Let me give one last question. This is your third question, which you have to solve by using negative indexing. ILOC negative indexing. Is this thing clear, everyone? Yes.
Yes, Vipul.
All right. One more thing. If you want subset of columns by using ILOC, uh, let's say you want not only consecutive column, you want market, number of orders, and sales. So which is 0th column, 2nd column, and 4th column, right? So let's say you want row number 1 to 9. So you'll write 1 to 10. And for column numbers, so you'll create a list, column 0, column 2, and column 4. That has to be sales 1. Just a minute. That means 1 to 10. Sales 1, row number 1 to 10 if I write for all the columns. Okay, ILS is missing, sorry. My bad. This will give all the columns out there. If you create a list 0, 2, and 4, you are going to get the output, right? So 1 to 9 for only market, uh, number of orders, and sales, right? So likewise, you can play with your data and you can create different combinations of subset uh, by using LOC and ILOC over there, right? A simple indexing, simple slicing we can have for your data, which is a very, very simple one by using no any function out there. So I'm explaining third method to for subsetting of the data, which is sales 1. I want uh, row number 1 to 5, let's say. So I'll write on 1 to 5 for all the columns out there, right? Here, it will not work for selection of multiple columns. You can write down this. I think, yeah, it will not work. You can only specify the rows that you want, that's all, by using this. Only the rows that you want, 1 to 5 or 4 to 12. You can specify only rows for all the columns out there. So this is just plain subsetting by using only row indexing. So this is third method, right? Now it's very important to have filtering of the data. We'll go with that. Example number 4, filtering of the data. Let's say you are interested to display markets with sales greater than 3 lakh, right? Uh, you'll quickly go with your sales data. You'll see, do we have 3 lakh? Yes. So I want to only subset the records for sales greater than uh, 3 lakh, right? So I'll select column data frame name. The column that I wanted to subset is sales, which should be greater than 3 lakh. If I do this, it will just only do the conditional check. Wherever this condition is getting satisfied, which is greater than 3 lakh, you are going to get true as the output over there, right? But I want to get the rows. I want to get the rows specifically. So it's very simple. You just put a square bracket of one more square bracket over there, this one. You're going to get the output for that. So for this rows, you will only get the rows which satisfy this condition where your sales is greater than 3 lakh. Is it correct? Is it clear, everyone? Very simple. It's not that. Yeah. Now, yes, what about others? I can see only few responses. If you're not understanding, you can directly ask. I'll explain it multiple times. Yes. What about other guys? Murali is good. Naveen is good. Ishwarya is good. Karthik is good. Okay. Okay. Excellent. You can ask your doubts if you have any questions. Don't hesitate to ask your questions.
Hey, hi, Vipul.
Yes. Yes. Go ahead.
So there is a function, right? LOC. So in that, so we are using columns with the name, name of the columns to
Mm.
sort and bring the data. So likewise, if the column is suppose if the index is region, so can we use the region names in place of rows?
Right. 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 I told no in the beginning. Suppose this is your region, this is your row name. So you have to use row name for that. You cannot use column, no? Sales.iloc. Uh, you cannot use row number. Let's say row number 1 to 4. You can use that, but it will be a little confusing for you. Let's say in this data, sales data, your row index predominantly uh, have text node. It is not a number. Obviously,
Yeah, that's what.
this is 0, this is 1, this is 2. But you can do that. Let's say you want Western Africa, Eastern Africa, Central Africa, this 3 part. So sales.iloc, Western. Let me copy this.
I think ILOC will only accept integer, right? LOC.
Give me a minute. Let's say I want Western Africa. Right index, it is integer based location, so you cannot use it by LOC, but you can use it by LOC, normal LOC. ILOC will not work for this. You have to use index, integer based position. See, if you go to official documentation, pd.iloc, it will explain you the fact that you cannot have a text kind of thing over here. Purely integer location based indexing for selection by position. It means purely integer. It will not allow you the text.
Okay, got it.
It's primarily integer based position starting from 1, 0 to length of the axis, but may also be used with a Boolean array. And you will find explanation over here, which I have given. They have created some examples for you to uh, understand it in more detailed fashion. This one. So I generally recommend learners to go through the user manual of all the libraries out there. You don't need to go anywhere else. if you have any questions, let's say you are good to go with this now. But let's say in future you're not understanding where you are doing wrong, right? Suppose this ILOC and you are making this error. If you just scroll down, this is your error, right? So the first way to resolve your error is directly search this on Stack Overflow, where you'll get n number of explanation, which I would say 80 to 85% you'll get resolution over here only. But sometimes if the author is not from, let's say if the author is from US, uh, you get confused from their solution, right? That is not very apt. So you should follow this thing for that, right? You will get a solution for this, but you have to read this and be patient. Most of the times we get solution from this only. But second reference, you should have this for your user documentation, official documentation. So it's always very useful to go with the official documentation of any libraries out there. If you want NumPy also they have official documentation for all the functions out there. You can see over here, right? So that is something that I wanted to tell. Coming towards your question, ILOC will not solve this, but LOC will solve because that is a location, right? So you can give, let's say, from Western Africa, sales dot head. Let's say I want Western Africa, North Africa, and Central Africa. I want this. So I'll create a subset of a list. In that, I'll write down Western Africa. Let's take North this time, right? And let's take last, which is Central Africa, this one. And for all the columns, this is missing. If you don't give square bracket, that is also fine. Too many indexes, is it? Comma should be there, no? I have given colon all. Yes. So this is your subset of a list that you can create if you don't want it continuous. If you don't use a subset, which I'm doing, you'll get error. Simply you just put everything in a list, right? Everything in a list. If it is not a continuous, if it is continuous, let's say Western Africa to Central Africa, you want, then there's no need of adding your subset of a list. Right here, you should not add a list. But as this is not a continuous, so you have to create a list, right? Okay, so that's what we have. Filtering is done for all the records which is greater than 3 lakh. Then, yes. Now, another question that you can have is you want to display only Latin America and European countries with sales greater than 2,50,000, right? Display only Latin America and European countries with sales greater than 2,50,000. How can you do this? You'll write on sales. Okay, and let me do it very simple. This is your data sales. I want a condition where market for the market column, I'll use one keyword which is very new for you, is in, where market is in which segment? This one, Latin America. So we are filtering this. Market is in. Market is in what? Latin America, this one. And European countries, right? So we want another condition, that is Europe. Let's create a subset of a list and add Europe. The condition is satisfied. Uh, let's close this. Okay. Now, second condition is sales greater than 2,50,000. And both the conditions should be satisfied. Both the conditions should be satisfied to get the output. So, which logical operator should we use? And or? Which one we should go with for this condition?
Right, and
It is and. Very good. Very good. So I should go with and. If I use or, it will not, it will work, but the output that I am supposed to get, which it will not give us, right? So sales greater than 2,50,000. Sales greater than 2,50,000. Right? If I run this, I'm not going to get the output because I have to put another extra bracket to get to filter the data out, and I should close it over here first. Here also I should have a condition like this, and here extra square bracket should be closed. Truth of series is ambiguous, is empty. Okay. If I use symbol and let's try that. Okay, this is working. Symbol is working and condition. So this is your and symbol, and for or symbol, we have this. I mean this one, right? So it is in my keyboard. It is about to the enter button. I press shift plus the key that I have, which is about to central enter button, which is this one. Yeah, which is this one. Can you see this? This one. So this is your or shortcut or symbol. This is used for or, and this is used for and, as you know this. But this is used for or, right? So if the condition is more complex, you will see this will easily work true and false, right? But here, as it says, it's ambiguous. The truth value of a series is ambiguous. So you are supposed to use and this, right? And here also you can use and. So this is how you put a condition, and this is known as is in, which is also very important, which says that market is equals to Latin America or Europe. This way. So is in is something which you should know to filter the data out, right? Now quickly we'll go to another example. Example number 5, which is transformation. The above example or the example that I'm going to take now are good to know, but not essential to achieve the objective of this session. In this session, we are not going to discuss transformation, which is something which we are going to discuss after some modules. If you see your syllabus, we have transformation, but that is something which we are going to touch after some days. But you can go through this transformation as just for your quick introduction. You can go through them at your own space. But don't worry if you're not understanding this as of now. We have a separate module for that, right? So I'm going to replace sales value in the form of thousands. And context, I'll tell you. Sometime what happens is you might want to modify columns to make them more readable. For instance, the sales column in the given data, say it as 6 digits followed by 2 decimal places. So you might want to make it more readable, and you can convert the actual sales number to a number in thousands and make it a round figure, right? Uh, just a minute. Take this here, right? So you can read this. You might want to make it more readable. So you can convert the actual sales number to a number in thousands and make it round figure. What I want to say is, wherever this sales is 66,56,636, I want to divide that with 1,000. I only want output like 656,000, 252,000, 461. That's it. So what I'll do is I'll write down example. Let's say if it is 3 lakh like this, so it should be 300K. So you can use Floor division to achieve the transformation explained above. So what I'll do is I want sales column. So I'll select sales dot sales. Selecting a sales column is equals to sales dot sales dot Floor division and 1,000. I'm going to write on sales dot head. So I'm dividing that particular thing and I'm doing Floor, which is let's say if you are if you have this number 1 2 3 4 5 6.78 and you're dividing that with 1,000, right? So we are just understanding what is Floor division. So if I divide this by 1,000, it will be shifted to 3 decimal places. It will be 123.456. What does this Floor division will do? It will round this off. Let's say this is 123.4, no? So it is obviously 123. If it would have been 123.78, then that time it will be 124. So if you see, we do not have any values after decimal places. Can you see this? It's a Floor division, right? And I can rename the column name by using sales dot rename. Columns that I wanted to rename is sales column, and I want to rename this sales column to what? This sales column to sales in. So you can give any name. I am giving this sales in thousands, and I wanted to do permanent changes on my data frame. So I'll write on in plus is equals to 2. I'll write on sales dot head, which will give me the top 5 output, not top 5, first 5 output. So this is how you rename sales dot rename. Columns you need to specify which column. Sales column, that name should be replaced with sales in 1,000. This will do permanent changes. So that is what we have to do the permanent changes. Is it clear now? Yes, everyone. You go through the recording one more time because I understand this will be little challenging for you as of now. But anyhow, it's not that difficult. So don't worry, it's not that difficult. Just a practice game, that's all. Right? Now we'll see how to use lambda function to uh, do some mathematical thing. Let's say I want to find total of profit column. Sales dot profit dot sum will give me the total sum, right? Total of all this profit. So if I just check what is total, it is this one. Now what I wanted to do is I wanted to create uh, one more column, let's say, which is profit percentage in total, which is profit percentage in total, right? Which is profit percentage in total, which will give you, suppose this is your 129 minus 12901.51. You will divide with this total sum and it will be percentage. Let's say 5.71 percentage. This one is 2.1%. This one is 4.9%. So I wanted to create one more column by using lambda function. So how can you do this? You'll write on sales. You'll write on the column name of the new column, which is profit percentage of total. You'll write on is equals to sales dot profit dot apply. You'll use lambda function x2 x divided by total underscore sum into 100, and you are going to write on sales dot head, right, which will give you profit percentage of total. So you are going to apply lambda function for that particular record. You are going to divide that with total sum and into percentage, right? And you suppose you don't want negative profit records in this because it is resulting us in negative percentage. So you want to eliminate the records wherever you have profit is equals to negative, right? Wherever there is negative profit, you want to eliminate that. You want to remove that. So you'll use LOC for that. Sales of profit, sales of profit, which should be less than 0, comma, for all the profit out there. You're replacing that with np.nan. NN means not number. And if you write on sales.head, which will give you the head in the output, which is wherever there is a negative profit, you can see it is replaced with not a number. So you can check this was negative, Western Asia was negative, Western Asia was negative. So it is replaced with the NN, right? Now I'll give you some time to go through this. I'm just quickly uploading this on your drive. So you quickly go through that. I'll take a break. We'll have a break, but I'll suggest you to go through that so that you'll get a better understanding again. And if you have any questions, you can ask it after your break, right? So you go to your drive, everyone. Go to your drive. On your drive, I am creating a folder. I'm creating one folder. Just a minute. Let's say this is the folder name is day 8, day 8, 27 October, right? And in that, In that folder, I'm going to upload this uh, I'm going to upload this file as well as data set, so you can directly take that out. I'm sharing this link with you. All right. All right. Now, do you guys have any questions in this indexing and slicing? Yes. Anybody have any questions? Yeah, I can see only 2 or 3 responses. Yes. After reviewing it, we'll ask. Yes, you can take your time. See, I told you this is little challenging because we have used lambda function, we have used is in Fleur division. But as this point of time itself, you should only focus on the logic. If you're understanding this, why we are doing that, then that is sufficient. If you practice it multiple times by using different examples, you'll get to know. But anybody here, if you have any question, like if you are not understanding, let's say anything, you can ask. For example, if it is in not clear, or if the lambda function is not clear, if Fleur division is not clear, you can ask. Yeah. Okay, you go through this. I have shared the drive link. Let's have a break for 10 minutes. I'll be back at 10:12 exactly. And we'll see the next part, right? So let's have a break. Yes, Kanan, in place is equals to true, will do the permanent changes on your data. So what we are doing, we are renaming that column to sales, no? Just a minute, where is that? Here. We are renaming this sales column to sales in 1000, and I want to have permanent changes on my data frame. If I don't write say in place equals to true, and if I just restart that particular sale, and if I just go to the okay, what I'll do is let us take this, let us do it over here. Let's comment this. Let's remove in place is equals to true, right? And let's restart and run all this. Let us restart and run all this. Now see, as we are not writing in place is equals to true, we are not writing in place equals to true, you will not be getting the permanent changes on your data. The changes will not be permanent. Where is that? Yes. Can you see here? It's not happening,
Yes.
right?
Hmm.
See, if I rename this, it will work over here. But if I again check my original data, sales.head, sales in 1000 is not there. Can you see this?
Yes.
So this in place is equals to true. Make sure that it is there permanently on your data.
Okay.
And you do n number of times now. You check sales.head n number of times. You will be having that. Right? All right. Now, the next thing that we have, okay, let me, okay, I don't have any questions. The next part is your operations on data frame. So for that, I'll create new notebook. Let's close this. Let us write down operations on data frame. And today's date is 27th, right? 27th October. So far in this session, you have been working with dummy data set, and the functions that were performed on the data were more theoretical than practical. From this point, you will be working with a real life data set. I'll share that data set on your drive, and I'll just explain the background of that particular data, right? So it is very, very interesting. If you just practice this particular case study, and if you are confident in that, uh, we generally do the same operation of cleaning the data, doing some manipulation on the data. Uh, it's more over 90% same and more analogous to this case study. So for this, you will require a data set. I'm just quickly uploading that on your drive. I'll just rename this as operations on data frame. And you guys will require, I have three datas for this particular thing, but let me check which data we require. Okay, weather data is something which will default. Yes, can you just check on your drive? It is on day 8. You just go to day 8. You have folder over there, operations on data frame. And over there we have three data. I have shared three data set, right? For that, you just need to download the weather data. I'll just share my screen. You need to download this part, this one. As of now, we are going to use this one. So just make sure you have this data with you, weather data, and let me know if you're done with that so that we can start the case study. Right here, I will upload that particular file, which is weather data CSV. I'll upload this, and this is your thing. Okay. Now, in this thing, as I told, it's very similar to the thing that we do in the industry. I have operations on Pandas. I'll write down what we are going to learn from this session. So this notebook will cover the following topics. Guys, just give me a minute. Just give me a minute. All right. Kindly share the weather data again. I've shared, no, it's there on your drive. Can you check that? Just refresh that. You'll be getting. Can anybody confirm? Is it there or not on your drive?
It is there, Vipul.
Yes. Okay. All right. So, we are going to see filtering of data frames. In that, we'll see single and multiple conditions. We'll see how do we create new columns. We'll see how do we create lambda functions. We'll see group by and aggregate functions. We'll see how do we select of pivoting the data, merging data frames, and in that merging, we'll see joins and concatenation. Right now, the background of this particular data is, let me first of all import pandas as pd, and let's read that data. Data is equals to pd dot read. The file is having CSV extension, no? CSV, yeah. So I'll just copy this file and upload it over here. Run this. I'll just check data.head, which will give me the data. Now I'll just we'll just discuss what this data is all about. So it's an FMCG company, P&J. They have found that sales of their best-selling items are affected by weather. So what they did is, let me take that out. I'll just take the description. Affected by weather and rainfall trend. So for example, sales of tea increases when it rains. Sunscreen is sold on the days when it is least likely to rain, right? Or when the sky is clear. They would like to check whether the weather pattern play a vital role in the sale of certain items, right? Hence, as initial experimentation, they would like you to forecast the weather trend in the upcoming days. The target region for this activity is Australia. So you will see that all the data is from Australia. Accordingly, this exercise will be based on analyzing and cleaning weather data from Australian region available on public platforms. So that's what we have for this data, right? Uh, I'll just take that out so that you can read this. Just a minute. Okay, this one is. So this is your dataset description, right? All right. Now let us start working on this. In this, we have date, location, minimum temperature, maximum temperature, rainfall, evaporation, sunshine, wind gust direction, and wind gust speed. Uh, so this is generally known as data dictionary. What is data dictionary? It just explains the column and its representation. Like date is what does this date will tell you? What is this minimum temperature? What is this maximum temperature? What is rainfall? What is evaporation? What is sunshine? What is wind gust direction? And what is your uh, wind gust speed? Right? So it's all written over there. The date is nothing but date on which recording was taken, location of the recording, minimum temperature of the day of the recording, maximum temperature in the day of the recording, rainfall in evaporation, so-called class A pan evaporation in the 24 hours to 9 a.m. Sunshine is the number of hours of bright sunshine of the day. Wind gust direction is the direction of the strongest wind gust in the 24 hours to midnight. And wind gust speed is speed in kilometer per hour of the strongest wind gust in 24 hours to midnight. Now let us start working on this case study. So what we generally do is we'll just filter our data frame. So I'll put heading as filtering data frames. In that, I'm going to find the days which had sunshine for more than 4 hours. And these days will have increased sales of sunscreen. Increased sales of sunscreen. So the day where we have sunshine more than 4 hours, that will be a particular day which will be having more sales when it comes to sunscreen, obviously, right? So I'll quickly check shape of the data. We have 1,42,193 rows, and we have 9 columns. And I am just interested to filter out sunshine column where there is more than 4 hours sunshine. I am just interested to check that. So this is just a conditional check to get the exact values. What should we do is we should write down this, right? Now, high sunshine corresponds to low rainfall. Can we say that? Can I say this? High sunshine corresponds to low rainfall. Yes or no? Are you agree with this?
Yes.
Now I want to filter out data frames by taking the consideration the cold drink sales will most likely increase on the days which have high sunshine, which is greater than 5, and high maximum temperature, which is greater than 35, and I need to use the filter operation to filter out these days. So data is nothing but data of maximum temperature is greater than 35 and data of sunshine it should be greater than 5. So data of maximum temperature it should be greater than 35 and data of sunshine it should be greater than 5. So we are filtering a data where cold drink sales will most likely increase on these days where your high sunshine is greater than 5 and high maximum temperature is, maximum temperature is greater than 35. So you can see these are the data points. We have 3861 rows and 9 columns for this condition, right? Now the construction of the filter condition, it has individual filter condition separated in parentheses. This is very important. So I am writing down a note for that. Note this out is the construction of the filter condition that it has individual filter conditions separated in parentheses. Separated in parentheses. Now I have example 2.1 which says creating new columns. If you notice, for some of the columns out there, data type is object, right? Let's say for date, data type is object. It should be date time. So there is one data type which is known as date time, which is related to your date format. So as this date represents the date, it has to be in date time. It should not be object. What do you mean by object? Object means simply a string type of data. Object means simply a string type of data. So location is Albury location. This is your string data. So location data type is object. This is justify. Uh, we can do justice for this. This is justifiable. Location is object, correct. Wind gust direction, it is in object. Let us discuss that. Wind gust direction is nothing but it's west or west southwest or northeast or west or west. So that is something which is in your string data. But what about this wind gust speed? It's a integer, no? So it is float, correct. Then wind, sunshine is float. Yes. Rainfall, again, it's a number, so it's float. The only thing that is not uh, looking good is your date data type. Except that we have all the data types which is correct and which is making justice to that particular column. But date should be date time, right? Date should be date time. Now I wanted to create new columns for this. So I'll write down, if you notice the filtering done in the earlier examples did not give precise information about the days, the data column simply has the dates. The date column can be splitted into the year, month, and day of the month column. So there is one special module of Pandas, which is the date time index, is a particular module which has the capabilities to extract a day or a month and year from the date, right? So if I run this, I need to convert that into date time index format. So we have one function pd.date time index, and you just need to specify for which column you need to do that. Now it is converted into date time. You can see that data type is date type, date time, and we'll just study date time format now. Date time function, and its attribute, which is there in your syllabus. So for this date time, for this date, I just wanted to extract year. So this is your year, right? For this date time, I wanted to extract month. I'll write a month, right? And we have day as well for this date time. Just wanted to extract day. This small day. Yeah. So if you see, this is one, right? 1st December 2008. We are extracting year, so it is correct. Then month is also 12, it is correct. And we have a day, that is 1. So this is how you extract from the date time column out there. Now what we'll do is we will take this out here and we will create a new column in your data. This is how you create a new column in your data. And we'll just store that in your year column, this one. We'll just store that in your year column. And if you write down data.head, you can see that we have created new year column, which will extract the year from this date and which you can see at the end of this data, right? Similarly, as I have explained, month also you can create a new column for that. Data of month is equals to this data of day month or day of month is equals to pd.date time index data of date dot day, right? And if you check data.head, let's say first 20 records, you can see that we have created 3 new columns. You can see that we have created 3 new columns, which is year, month, and day of the month, right? Is it clear now, this one? Anybody have any questions in this? All right, excellent. Now I'm interested to create new columns. The temperature given is in Celsius, and we need to convert it in Fahrenheit and store it in a new column. for it. What I'll do is I'll write down data. I'm interested to create another new column, which is max temperature in Fahrenheit. And if you see conversion of Celsius to Fahrenheit, it is, suppose, let's say you want to convert 15 degrees Celsius to Fahrenheit. So it is 15 into 9 by 5 plus 32. Remember, this is your factor, 15 into 9 by 5 plus 32. So 9 by 5, you have to multiply this and add 32 to that. So what we'll do is we'll extract maximum temperature column, which is in degrees Celsius. I want to multiply that with a factor 9 by 5, and I want to add 32 to that. And if you just check head of your data, you will be getting Celsius to Fahrenheit, right? So you can just check 22.9, is it 73.22? Let us check that. It is correct, right? Again, take a random value, 25.7. It gives 78.26, and this is correct. So that's how you create new columns and do some mathematical calculation, right? Now, anybody have any questions in this? You can ask. If you have any doubts, you can directly ask. I'll wait for your questions before proceeding further with the new part. Yeah. Any doubts? Gopi, Hari Krishna, Janani, Avantika, Kannan, Karthik, Madhu, Maulya, Murli, Navin, Sharmila, Srikaran, Jayachandran, Varun Karthik, Venugopal, and Vijay Kumar. You guys have any questions? Binu, Arun, Abdul, Darshini? No? All good? Okay. It's good that you don't have any questions. Then it seems this batch is good. All right. Excellent. Now let's create a new column which highlights the days which have rainfall more than 50 mm as rainy days, and the rest are not, right? Let's create a new column which highlights the days which have rainfall more than 50 millimeter. If you have rainfall more than 50 mm, let's call that particular column as rainy days, right? And the rest are not. So how to do this? By using lambda. Now again, this is very interesting. You have to become, you have to be comfortable with your lambda functions, because that will be your friend for a life, for your analysis or any project out there, right? So you need to learn how you can use lambda functions n number of times in any use cases. Now let's say, what is your lambda function? What is your case? You want to filter the data where there is rainfall greater than 50 mm. You want to just put that as your rainy days. So I'll write on lambda x. I'll write down rainy. This should not be there. X for rainy if your x is greater than 50. If your x is greater than 50. Else, if it is not greater than 50, I'll write down not rainy. I'll write down not rainy. So this is how you apply filter, which is lambda, for your this thing, your condition, right? Now, there's one note for you. I have new way of accessing a column in a data frame by using the dot operator. Second is apply function takes in a lambda operator as argument. New way of accessing a column in a data frame by using dot operator. So what I'll do, I'll write on type of data dot rainfall. It's a series. I'll just check type of data of rainfall. You can check like this dot or this, which we already have discussed, right? So it's a series because we have not converted into data frame. If you want to convert this particular thing into data frame, just add one more square bracket to that. Or you just can do one thing. This particular thing, you'll write down A is equals to PD dot data frame of this particular thing, which we'll see afterwards. Don't worry. And if you just check what is there in A, so it will be a data frame. Print A. Right? This is how you convert anything into a data frame. But that is not something which we are going to do now. So let us keep it as your series object only. This one is a series object. Let's create this as series. Now, again, what we are interested to do is in our data, wherever there is raining column, or wherever there is rain fall, which is greater than just okay, wherever there is rainfall greater than 50, we wanted to add a label to that particular column as is raining, right? Wherever rainfall is greater than 50 mm, we'll create new column for that, which will be is raining. And that will be rainy days, right? Suppose in your data, if you observe rainfall, don't we have rainfall greater than 50? Just a minute. Not rainy, not rainy. All the columns are not rainy. Earlier 0.6. We had 0.6. Okay. It seems like all the columns are okay. Let's check because we are not getting all the information from the data. We are going in the correct direction, but I wanted to just label rain spelling is wrong. No. I just wanted to check a label wherever there is greater than 50 as uh, rainfall, wherever rainfall is greater than 50, I wanted to label that as rainy. That's let's see this. So what I'll do is I'll create one more column by using lambda function. The column name is underscore raining is equals to data dot rainfall dot apply lambda for x particular value rainy if x is greater than 50, if x is greater than 50, else not rainy, not rainy. We'll note that the above code is also another way to find this. No, who is asking this? Darshini, it's not like that. We are just filtering out. No, we are not applied the condition wherever the rainfall is greater than 50. We are just applying that condition. Wherever that it is getting satisfied. Can you see this? Lambda x equals to rainy if x is greater than 50, else it is not rainy. So if your rainfall is not greater than 50, you will get not rainy over there. If it is greater than 50, then it is rainy.
Yes, sir, but the data is in range 0 to 1, right, sir?
Yes.
0.6, the data is like that only, no, sir. So all of them will come out to be not rainy only, no, sir.
We'll see that. That's what I told. No, we are not getting. What about this data? We have 1,42,192 records. There might be data which is a rainy, which has rainfall greater than 50. We'll see that. I'll just tell you.
Okay,
We have
sir.
data. We have data. Don't worry. We have that particular data which has rainfall greater than 50. Now note that uh, you can do same thing. You can do the same thing by another code, which is also very simple. I'll write down that. Above code is also another way to find this. What you can do is instead of selecting a column by using dot, what is your alternative way to select a column? Do you agree with this? We have data dot rainfall. We have data of rainfall. Yes or no? See, if I write down data dot rainfall, I can select that particular column. If I write down data square bracket in quotes that particular column, I can select. So you can write down that, right? Yes or no?
Yes, Vipul.
So if I run this, that is also something which is going to work. And now let's check this. Now see Harshini, we'll get this. What I'm doing is raining is equals to rainy. This condition I'm applying. See, we have data. Can you see rainfall is 52.2 or rainfall is 66, 50, 52. Yes or no?
Yes, sir, yes.
So that's what we have. You can try this. I mean, not try, you can go through this. And if you have any questions, you can ask. I'll take a pause for 2 minutes for your questions if you have any. Yeah, is it clear? This one, everyone? Now let us add one more example. Let's see how do we do grouping and how do we use aggregate function for that, right? Uh, okay, just a minute. Yes, grouping and aggregate functions are two of the most frequently used operations in data analysis, especially while performing exploratory data analysis, where it is common to compare summary statistics across groups of data. As an example, in this weather time series data that we are working with, you may want to compare the average rainfall of various regions or compare temperature across different locations. Yes or no? So you want to do a grouping analysis that can be thought of as having the following three parts. You need to split the data, you need to apply a function, you need to combine the results into a data structure showing summary statistics. So that's why grouping is necessary, right? That's why your grouping is necessary. So let us put a heading as grouping and aggregate functions. This two functions are two of the most frequently used operations in data analysis, especially while performing exploratory data analysis, which is EDA, where it is common to compare summary statistics across groups of data. So as an example, in the weather time series data, in this data you are working with, you may want it to compare, or you may want to compare average rainfall of various region, or compare temperature across different region or locations, right? Now, a grouping analysis can be thought of as having a grouping analysis can be thought of as having the following three steps or three parts. First is you need to split the data into groups. For example, groups of location, year, and months. You need to apply, you need to see applying a function on each group. Example, mean, max, and minimum. I need to see combining the results into a data structure showing summary statistics. Right? Now see this example. I wanted to find the location which received the most amount of rain in the given data. I wanted to find the location which received the most amount of rain in the given data. In this place, certain promotional offers can be put in place to boost sales of tea. Yes or no? Or umbrella. So where there is a well, if we are filtering a location where there is the most amount of rain in the given data, certain promotional offers can be put in the place to boost sales of tea or umbrella, right? Or several different things which is related to rain. So what we can do is let us quickly check head of the data and tail of the data. It's not necessary, but I am interested to check this. Rainfall is something or location. Okay. Now what I'll do is I am introducing another function which is group by over here. So suppose data by location is the column name or the data frame name that I wanted to do. How do you use group by? You can use it like this. You can write down by is equals to on which column you wanted to do group by. By is equals to location, and you write down mean of that particular column. So location mean. You wanted to find mean of all the columns location wise. Mean of all the columns, let's say mean of minimum temperature, mean of maximum temperature, mean of rainfall, mean of wind gust direction or wind gust speed. Only numerical column we can do, right? Can we find mean of this evaporation, wind gust direction, the text column? Can we find mean of that? Can we find mean of this east,
No.
west? You cannot
No.
find.
Yes.
Only numerical column will be there. So if you see, we have minimum temperature, maximum temperature, rainfall, evaporation, sunshine, wind gust speed, year, month, day of month, right? And suppose you wanted to, now again, this is very important function, group by, which you need to understand how you can use that, because it is used to filter the data out by different condition. And in this thing, I wanted to sort the records in ascending fashion or in descending fashion. I wanted to sort the record in descending fashion. If you see, as of now, this is in ascending fashion, or it's not in ascending fashion. It's randomly. Can you see this 36, 32, 40? So according to rainfall, I mean, for rainfall, I wanted to uh, sort this values, sort underscore values, rainfall column, comma, ascending is equals to false dot head. If I do this for rainfall column, if you see, I have done in descending fashion. So what is this ascending is equals to fall? It's a keyword that we have. Ascending is equals to fall, is equals to false or true. Ascending is equals to false means descending, right? And if you ask like, can't we write down this by descending is equals to false? So we don't have a keyword for that, right? They have created this programming language where they have not added this keyword descending is equals to false or descending is equals to true. So the error is sort underscore values got an unexpected keyword argument which is descending, right? It simply means that you don't have descending keyword in your sort underscore values method. So what is your keyword? It is ascending. So if you want to do descending fashion, so you should write ascending is equals to fall. And if you don't write anything, by default, it will be your ascending. Right? If I don't write anything, let's say, by default, it is in ascending fashion. Can you see this? From lowest to highest, from lowest to highest. Here we have from highest to lowest. Yes or no? Yes. Is it clear now, this one?
Yes, Vipul.
And last but not the least, last for today, we have grouping and aggregate function. Suppose one case study is hot chocolate. For hot chocolate, just a minute, let me check data.head. So we have that. Okay. Hot chocolate is the most sold product, I can say, in the cold months, right? Now you need to find month which is the coldest so that the inventory team can keep the stock of hot chocolate ready well in advance. The stock of the hot chocolate ready well in advance, right? So I'll write on data by month is equals to data dot group by is equals to month dot mean. And if I just write down data by month, so you're going to get this output, which is we are finding the month which is coldest so that the inventory team can be can stock the hot chocolate ready well in advance. So wherever there is minimum temperature very lowest, we'll need to sort this. So data by month, what I'll do is I'll sort these values by using minimum temperature, right? Because this is something which we are interested in. So as I'm not giving ascending is equals to fault, by default it will take ascending is equals to true, and the lowest temperature is 6.95 degree. This is Fahrenheit, no? No, this is degree. 6.95 degree, 7.46. So it's a cold region. You can see that 7th, which is July month, August, June, this is October, May, are this month where the minimum temperature is less for that particular. So you need to do that. You need to sort that. I mean, you need to stock the hot chocolate ready well in advance for your FMCG company before this particular months, right? So this is how they do the analysis on the real life data, right? Is it clear, this part? Yes. Anybody have any questions till now? Okay, all right. Then you will stop here for the day. If you have any questions apart from this, you can ask. Can we
Yeah,
group?
yeah, Vipul.
Yeah.
Yeah, can we add multiple column in the sorting? Right now we are actually sorting one column, right?
Just a minute. Give me a minute.
Okay.
What is your question? Sorting.
Yeah.
Can we have it for multiple columns? Yeah, you can have, no?
Okay. I think group by we have added the square bracket.
Yeah. Square bracket means you can do group by based on
Yeah,
different.
yeah. That is okay for the sorting. Yeah. Same the way, right? Okay.
But there is no any point of doing this. Anyhow, let's see this. Suppose I want.
Yeah.
There's no any point, no?
But here in this case, we actually grouped by the mean values. But sometimes when we have different data,
Mhm.
yeah. So there is no point here. So I just asked, is there any option?
Yes, correct. I mean, I am just stating the fact that we generally don't use sort underscore values for multiple columns,
Okay.
but we can have this.
Okay.
The multiple
Thank
columns,
you.
you can give any columns, no? Rainfall,
Mm,
then sunshine, this one, right?
Okay. Okay. Thank you.
Yeah.
Mm.
Mm. For group also, you can do this. Sometimes you have to group by based on multiple columns. We'll see that. We'll see that. I have one beautiful question. I was I mean I was expecting that somebody will ask this. Uh, Suppose here what we are doing for month column we are finding mean, right? For month column we are finding mean. But what if I want, let's say, minimum temperature, I wanted to find median of that, not mean. Uh, for maximum temperature, I wanted to find, let's say, mean, that is average, mean. And for other columns, let's say for rainfall, I wanted to find maximum value. So basically, the question is, what if you want to find different statistical term for multiple columns, not the same term? See, in group by, you can add columns and you can find mean of that, right? Let's say minimum temperature. You add it over here, you get it over there. You add another column and you'll get it. But that is only for same statistical term, no mean. What about if you want this different values? What can you do for that? Yes,
Do we need to add? Do we need to add the function in the second and third line, something like that?
functions. You mean lambda function, is it?
No. Not the lambda function. Go to the top. So in this line we have mean, right? So
Mhm.
second line we need to add the medium, something like that.
No, not like that.
Okay.
I wanted to do it in same line.
Then I don't know.
Yes. See, that's what I asked this question. You read about this, and in next session we are going to uh, discuss this, right?
Okay.
That's why I generally ask this. What you can do is I'll just put this as your homework. You read about this question. Think about this. How can you solve this? You think about this, everyone. Yeah? Is it clear now, everyone? So I'll quickly upload this on your drive. If you have any questions, you can ask in this. If anybody have any doubt, you can ask. Just can I use describe for this? Describe. This is not that simple question, Darshini. You can use describe, obviously. See, what is my question? Uh, okay, describe will anyhow will give you median and maximum, right? Right. Okay. Yes, describe is one of the answer, correct? But I wanted to use one function which we have not seen till now. Anyhow, this is correct. Very good. But think about this, how we can use group by function and find different terms. So group by associated with one thing, which is aggregate function. This is your solution. You read about this. We are going to see this in the next part. Right? Group by with aggregate functions. All right, I have uploaded this on your drive. You go through that. We'll stop here for the day. If you don't have any question, you guys will be having quiz now, right? So don't go. You will have quiz. If you have any questions, I'll still give you 1 or 2 more minutes. If you have any questions, you can ask. All right, then.
Okay, thank you, Vipul. Hi, everyone. So we'll be starting with the quiz. Before we start with the quiz, I have an announcement to make. Okay, so I'll just quickly share my screen. So here's a poster in front of you all. Okay, so this is something big we are going to do. So we have associated with IIT Bombay Tech Fest, and we'll be conducting an artificial intelligence workshop at IIT Bombay in during their Tech Fest on 18th and 19th December this particular year. So this is a paid offline workshop. So anyone who wants to register, you can register yourselves. Okay, I'll paste the link in the chat box. Okay, this is a big workshop. You'll be getting the certificate from IIT Bombay Tech Fest itself. So it won't be GUVI certificate; it will be from their end. And also, you'll be getting a chance to network with people from pan Indian, pan global level, because this is considered to be Asia's largest science and technology festival. So whoever wants to register, you can register with the link I've sent in the chat box. Okay. So this was a small announcement. For any further queries, you can drop a mail to us. We'll revert back to you with that. Okay. And even my name and number is posted in this poster. So if you want, you can take my number or my mail ID from there. I'm Yash, so you can take my name or mail ID from there, and you can ask me. Okay. Sorry. So now we'll start with the quiz. So yeah, Gopi, you can write anything. Okay, it's their directory. Okay. And one more thing to add, you will be getting the exposure of IT Bombay campus. So since this particular event is in IT Bombay campus, so you will be visiting over there. So once you register, you will receive your pass, your entry pass and your workshop pass on your mail ID itself. Okay. So that's the case. Now coming on to quiz. So we'll start with module 4 since I guess Vipul, module 4 is done for them, right?
Which module?
Module 4.
Module 4 is just a minute. Is it related to Python?
No, Python advanced one is not there. Fourth one is, I guess, EDA. No.
Just a minute, let me check.
Sure.
Okay.
Because I have two quizzes, one for Python Advanced and one for this one. I'll check with you and I'll give them that one.
Yes, yes, sure. Module 4 is Introduction to Pandas. Yeah, we have done that. Yes.
Okay, done. So we'll start with that itself. So rules are same. I'll be pasting the link in chat box. You have to join from your own screen. You don't have to look at the Zoom. So yeah, here's your link for today's quiz. Please join it soon. It's 11:21. By 11:23 and 24, we'll start the quiz. Seventeen have joined. Rest, please join soon. In next 1 minute, I'll start the quiz. Okay, we'll start the quiz. Okay. So first question is, what is the primary use of the pandas library in Python? Great, most of them are right. Avantika is leading after first question. Second question is, which of the following is a common data structure in pandas? Great. We'll move to third question. Still Avantika is leading. Third question is, how do you import the pandas library in Python? Great. Fourth question, what is a pandas series? Great. Fifth question, Which method is used to retrieve data from a Pandas series by position? How do you select a column from a Pandas data frame? Madhu is leading now. Question number 7. Which method is used to load a CSV file into a data frame? How can you select a subset of rows and columns in a data frame? Second last question for this week. What type of join is performed by default in the merge function? Last question. Which argument in the merge function allows you to specify the type of join? Example, left, right, outer. Nice. So we are done for this week's quiz. And Madhu is third. Anbu chosen is first. I'm not sure if I've spelled that name correctly or not. Sorry if I spelled it wrong. Karthik Shriniv is first. Okay. So thank you. And before we leave out from this meet, again, look after this opportunity to be a part of IIT Bombay. And topics, if I have to name down the topics, so topics will be related to more advanced AI, what we know as generative AI. So it will be LLMs, RAG architecture, and frameworks like LangChain and Hugging Face. So it will be a 14 to 16 hours of workshop. Okay. So yeah, we are done for this week. Thank you, people, for your time. Thank you, everyone.
Yes, everyone. Thank you. Happy learning.
Thank you, Vipul.